All right, so here we are with 3.3. This is titled Composition of Functions. So to begin with, we're going to start with some really basic level um, of some kind of compositions, mostly just teaching you how we're going to set these compositions up in the long run. So I have given you that f of x equals 3x to the half. Okay, this exponent here is a half. And g of x equals 7x also to the half power. Okay, so the first thing I asked you to find, I did this example for us beforehand, and we'll fill out the next one together. But I said find f of x plus g of x. So what you do is you take your f of x function, that is 3x to the half, and you add it to your g of x function, which is 7x to the half. Add the two of these up. If you think about these are both like terms because they have the same variable and the same exponent to that variable. So you can simply add the numbers on the outside to get 10x to the half. Or 10 square root x, if you're trying to think about that in a radical form. Okay, I would probably prefer this answer for this problem though. Next one, g of x minus f of x. So take our g of x function, 7x to the half, and subtract our f of x, 3x to the half. Again, consider same term, same kind of like term, 7 minus 3, 4x to the half, that one, okay? So the purpose of this is truly just grabbing what kind of function it is, what that function is, what it equals, and setting up the operation. Next one, f of x is 10x to the fourth, 1/4, and g of x is 10x to the 1/2. There we go. First, I want you to find g of x times f of x. So this is going to be pulling our g of x function, which is 10x to the half, and pulling our f of x function, which is 10x to the fourth. If you have same bases, okay, that being 10x and 10x, you keep the base, remember exponent properties, and you add their exponents. Okay, when we're multiplying, keep same base, add exponents. So we are adding 1/2 and 1/4. A common denominator here would be 4. So 10x to the 2/4 plus 1/4, equaling 10x to the 3/4 as a final answer. Same thing with division, taking f of x divided by g of x. Again, pulling our f of x, pulling our g of x, dividing the two. Same bases, division's happening, so we subtract their exponents. Again, go ahead and put those same common denominator exponents up here. 1/2 and 1/4 and 2/4. Meaning we have 10x to the 1/4 minus 2/4, or 10x to the negative 1/4, which in the long run would be 1 over 10x to the positive 1/4. Okay, remember, negative exponents say that we bring that down to our denominator and put it like 1 over what this number was before. Okay, last thing is true compositions. Okay, so before we were adding, subtracting, multiplying, and dividing. Now when I give you your f of x and your g of x, we are now going to take f of g of x. Okay, that's the way that we write that. Your book might have this f o g of x, kind of almost looks like fog. Both of these mean the same things. They're both mean that you have your f of x function and you are inserting your g of x function every time you see x. So again, the function that's written in front, both of which is f of x. That's the function you start with, okay? So 2x plus 1 is what we're starting with. Every time you see an x, that's where you put in your g of x function. So my whole g of x function is 3x. So instead of having 2x plus 1, I have 2, and then I start to open up a parentheses as soon as I see an x. And I say, nope, that's not x, that's actually my g of x function, which is 3x. You insert that entire function for the current x that you have. And then I have to keep finishing it up with this plus 1 and add that on. We simplify this out, it would actually be 6x plus 1 through multiplication. Okay, let's go the opposite way. Now they want us to take g of f of x. This could also be written GOF of x. GOF is what some people will say. This little tiny circle would be really small, like not like a O, but just a tiny little centered circle in between those two letters. When we take g of x, g of f of x, again, now you're starting with your g of x function, which is 3x. Every time you see an x in your g of x function, you replace it with all of your f of x, okay? So we start with our g of x, we hit an x, so we open up a parentheses. Our f of x function is 2x plus 1. We put that in for x, close the parenthesis, go back and check, do I have anything more? No, after x it's finished, so this is all I have. So if you multiply this out, 3 times 2x, 6x, 3 times 1, positive 3. It's going to be your answer there. Okay, let's step it up one more example. These truly, they seem a little bit complicated until you start trying them. The best practice is not for me to show you a million different versions of it, but the best practice is going to be for you to truly practice these on your own. So let's do an x squared plus 1 is f of x, and g of x equals 2x plus 2. Okay, so let's first find f of g of x. Again, I start with my f of x function. Right away, I hit an x. So I go ahead and I open it up. I insert my entire g of x function, which is 2x plus 2, and then I close my parenthesis because I'm done with my x. Now I have to say, okay, what else is left? A square is left, so I have to square that, and then a plus 1. So I add that to the end. You can absolutely distribute and FOIL this function out. I'm not going to for this example, just for the sake of time. But again, it would just simply be multiplying out 2x plus 2 times 2x plus 2. Now let's find g of f of x. So we go ahead and we start our g of x function, which is 2. Then we run into an x, so we open up a parenthesis. Insert our f of x function, which is x squared plus 1. Close parenthesis, that's the end of my x. Plus 2 would be the last bit of it. Super simple distribution. 2x squared plus 2 plus 2. And simplify this down to 2x squared plus 4 would be a final answer there. Okay, so composition of functions, taking one function and then another, replacing every x with that other function. That's about as basically as complicated kind of as we'll get, especially for this section. So you will have to be able to be confident in your compositions of functions in order to be successful with 3.4. So if you have any questions, please don't hesitate to reach out to me. Thank you.